As I said before, understanding the conventions of chemistry makes it so much easier to complete tests and studies and actually have a better understanding of what you're actually talking about. So one of the biggest things we have is the naming of organic compounds. Now, chiefly organic compounds have hydrogen present, and they can be in chains or rings or a combination thereof. And we can have, as we know, carbon can bond using single bonds, double bonds and triple bonds. So we have to be able to identify and be consistent with our naming so that people are able to understand which of the actual compounds we're talking about. So what chemists decided to do was to break the name into a prefix, the start of it, and talk about the number of compounds. And in this case, we'll talk about the chains. So in the longest chain, in our course, we only have to know up to carbons, the names of carbons, compounds that have 6 or less. But obviously carbon compounds can form these huge long chains such as DNA, rubbers, various forms of rubbers, and a lot of polymers that do exist. The ending of our name, we talk about the bonding between the carbon atoms. Now this is particular for all the hydrocarbons and all the groups that are derived from those, so our alcohols, aldehydes, ketones, etc. Numbers of carbons follow a real mixture of Greek and Latin that comes from early studies, and we can actually see from the next bit what the names are. Now your pronunciation, of course, might differ from mine. We have the long vowels and the short vowels thing, so please just make sure it's understood. Now if we have a carbon chain with only one carbon in it, which exists, a gas called methane actually exists, and it's just got a carbon and 4 hydrogens around it. Then if we extend and add another carbon to it, then we can have a carbon and carbon compound, a small chain, and we actually give the prefix eth with that, or eth. The next one, if we add an extra carbon, we form prop type compounds. Then 4 carbons tend to be bute. And around about the 4 carbon chains, we can have things like cyclo come into it, which means we form a ring structure. But we tend to find it's more than 4 tend to form ring structures because of the forces that need to be held together. There's a lot of strain on the bonding in a 4, in a square sort of shape. Right, 5 is named after the pentagon or pent, and 6, of course, is named after the hexagon or hex. Again, as I've said, we know that carbon can form single, double, or even triple bonds with other carbon atoms. Now, in the compounds we are dealing with, we are only supposed to know the naming for if they have 1 double or 1 triple, and how that affects the naming. Even though I could give you something like a basis of car tyre, which is 1,3-butadiene, which means I've got a double bond on the first to second and third to fourth carbons, 2 double bonds, and we have 4 carbons in the chain. It's a very interesting name, but that would be as tough as I would think you would get it. So if we then look at the suffix at the ending of the name, if we've only got sigma or single carbon bonds between the carbon atoms in the chain, then we would call it an ane. So if I had 4 carbons and only single bonds in it, it would be called butane. Right? If I had 5 carbons in the chain and they were all single bonds, then we would call it pentane. If I formed a ring structure, then we would call it cyclopentane, because it's a ring, cyclo. I've still got 5 carbons, so it's pent, and I've still got single bonds, so it's ane. All right, if I add a double bond in there, all right, so let's say I've got 2 carbons with a double bond, then that would be called ethene. If I've got 3 carbons and a double bond, it will be called propene. Now, we must tell the reader which carbon has the double bonds. So we actually talk about the starting carbons here. And for any carbon chain longer than 3, so when we've got 4, 5 or 6 carbons and we have a double bond, you must tell the reader where the double bond is. And you'll always talk about the number of the carbon atom that it starts in our chain. All right? So if it starts between the first and the second, we just call it starting from the 1. So we add the number 1 into our name. And it would be called, let's say if there's 4 carbons, and our first carbon to the second carbon had a double bond, that would be called but-1-ene. Now the reason we must use the numbers is because the double bond could be in more than one place. All right, the same applies for the triple bond. Instead of the ene, we call it yne, Y-N-E or yne. So if I've got a triple bond between the first and second carbons and I've got a 4 carbon chain, it would be called but-yne. Now, we have to remember, and this is discussed a bit more in other videos, about if we've got, based upon these hydrocarbons, we can add things to them to make a special group of compounds. For example, if we've got a hydrocarbon and we add a hydroxide group, then it's not a hydrocarbon anymore, it becomes a special group called alcohols. If we add an NH2 group to it, then it's not an alkane anymore, or an alkene, it is an amine. The NH2 group takes over, and that's our functional group. So we just have to simply remember these changes as we go through.